of natural numbers define the relation A is related to B if and only if GCD of A and B is 2. GCD means greatest common divisor. It is also called as HCF. You have studied this in your 10th standard, 9th standard. It's called as HCF, highest common factor. Or it's also called as GCD, greatest common divisor. Okay. Now, GCD must be 2, between two numbers. Then only they are related, otherwise no. Now, for example, what is the GCD of 9 and say 30? What is the GCD of 9 and 30? Means 9 and 30. ಈ ಎರಡು ನಂಬರ್ಸ್ ಅನ್ನ ಡಿವೈಡ್ ಮಾಡುವಂತ ಹೈಯೆಸ್ಟ್ ನಂಬರ್ ಯಾವುದು? Which is the highest number that divides both 9 and 30? It's obviously 3. It's obviously 3, right? So this is not included in our relation because our relation is defined as the GCD is 2. But here I'm getting GCD is 3. So this is not a relation. I mean 9 is not related to 30 according to this problem. Now if I take 4, 10, what is the greatest common divisor? What is the highest factor here? Which is the highest number that divides both 4 and 10? It is 2. So now you can say 4 is related to 10 according to this problem, this condition. Okay. So like this, GCD 2 barabekili. Then only those numbers are related. So this relation, is it reflexive, symmetric or transitive? Set of natural numbers anta ide. Obviously reflexive agalla. Because if I take 3 and 3, reflexive means A, A. If I take 3, 3, what is the GCD of 3 and 3? 3 and 3 GCD is 3 only. But GCD is 2 anta ide function, probably. So obviously this fails. This is not a reflexive relation. This is not reflexive. Symmetric agata. GCD of 4 and 10. Just now I gave the example. GCD of 4 and 10 is 2. Now if I reverse them, GCD of 10 and 4, it doesn't matter. Then also it is 2. 4 and 10 or 10 and 4, whatever you say, 2 is the highest factor. So 4, 10, 10, 4. A, B, B, A. So 4 is related to 10, 10 is related to 4 because GCD is 2. So it is symmetric. Transitivity. Transitive agalla anta ಹೇಳಿಬಿಟ್ರೆ, but give an example where that transitivity fails. Conditionally fail ಆಗುತ್ತೆ, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡಬೇಕು. ಆತರ ಎಕ್ಸಾಂಪಲ್ ಕೊಡಲಿಲ್ಲ ಅಂದ್ರೆ it's transitive. It becomes transitive. Give me an example where transitivity fails. Okay, 4 and 6. What is the GCD of 4 and 6? Obviously it is 2. Next, what is the GCD of 6 and 16? Then also it is 2. Right? 6 and 8 also you can take, no issues. GCD of 4 and 6 is 2. 6 and 16 is also 2. 2 is the highest number which divides 6 and 16. Now 4 is related to 6. 4, 6. 6 is related to 16. Now 6 is common here. So I get 4 is related to 16. But 4 is related to 16. Is it correct? No. Because 4 and 16, which is the highest divisor that divides both 4 and 16, it is 4. If you take 4 and 6, 2 is the highest divisor. If you take 6 and 16, then also 2. But now that 6 you have to leave because A, B, B, C. You have to take A, C. So 4 and 16 if you take, then GCD highest factor will be 4. But 2 anta ide. So this is example where transitivity condition fails. So whenever you check for these relations, you have to give the counter example. This is called as counter example. Counter example means where it fails. If it doesn't fail, if it's correct for all examples, if you think, then it is transitive, it's reflexive, you can say. So this is only symmetric. That's option